line symmetry pretty easily. But symmetrical to the origin, an odd function looks the same, exactly the same, right side up as it does upside down. Like think about a sine function. If you flip your head up, well, I got to go back this way too. If you do that, it looks just like that. It looks the same. Okay? All right, so on our notes, we're going to start with test 3. Your homework, obviously, tonight in test 3 is to keep going, do the second set of questions. But we're on 23. We did 21 and 22 yesterday. 23 just says to find the inverse. What's the back side of the flashcard say for finding an inverse? Which the x's and the y. So I'm going to start with 23 here, and instead of y equals negative 2x plus 5, I'm going to put x equals negative 2y plus 5. I'd be surprised if they wanted you to write the inverse to a linear function. That's a little easy. It's probably going to be more like a radical or an exponential something that they want you to write the inverse for. But the process is the same, although solving for y is going to be much easier here than it would be in another type of equation. So we subtract 5 from both sides, divide by negative 2, so y equals x minus 5 over negative 2. This function was f of x, so what am I changing my y into? F inverse of x. Yes? So, and they're saying, they're even going further, they're changing the entire name to g of x. Find g of x as the inverse of f of x. So theirs all say g of x equals. None of those looks exactly like the one I just got. I got x minus 5 over negative 2. I got this right here. Which one is the same as that? Correct, the first one. So you would just divide both pieces by negative 2. So that's going to make negative 1/2 x. And then negative 5 divided by negative 2 is going to make it plus 5/2. And so that is option 1. Good? Okay. Number 24 lists a table. It lists the number of Americans in thousands. So when it says 50, that means 50,000. When it says 56, that means 56,000. You cannot take for granted these little details of in thousands, okay, who are expected to be over 100 years for the selected years. X is representing the number of years after 2010. So 2014 is 4 years after 2010. That's my X coordinate. 2016 is 6 years after 2010, and so on. So it says to determine the quadratic regression. So you're not going to do this right now. I've already entered my data into the calculator. So stat, edit, and we have all our data in there. And then to run a regression, stat, and calculate, and it specifically tells us quadratic regression. So we don't have to create our own, we don't have to look at the scatter plot to tell. Okay, although if we did, my guess is it's going to look like a parabola. So they're having you do a quadratic regression. When you do your quadratic regression, you should already have list 1, list 2 in there, and you calculate, it's going to give you the quadratic format, and it's going to give you the decimal. So I've rounded all of these, except for B, because I didn't see a need to round it. I went out 3 decimal places. For A, I just went .40. For B, I did the whole thing, and for C, I went 48.34. And I wrote that equation. So then I have to use the quadratic regression. So use that equation to predict the number of Americans who will be over 100 years old in the year 2026. So what am I going to do with that equation if I want to find the number of people in 2026? Plug in 26. Plug in 16. If you plug in 26 or you plug in 2026, your number is going to be off the chart. You plug in the number of years after 2010 that it is. No, it's okay, so that's why. I wonder where you said 26 from. So the number of years after 2010, which is 16 years. So I will plug 16 in for my x coordinate. So 0.40 times 16 squared, whoops, minus 1.175 times 16, plus 48.34. And this answer is in thousands. So that's 131.94 thousandths, which is the closest to which number? 131, hold on. Which one's it closest to? 131.94. Option 4, 132,000. Good. So test 3 tonight? Second part? Goodbye. Thank you.